In this module, we will review some database basics and we will learn about normalization. This is an overview of the module. Any organized collection of data can be called a database. Nowadays, we normally mean a digital data collection when we say database. Depending on how they're organized, there are different database types. And the particular database type that we will deal with in this course are relational databases. In basic terms, relational databases are databases where data are organized into a set of two-dimensional tables, which are also called relations. The data in different tables are associated via relationships by making use of primary and foreign keys. To use a technical definition, a table is the primary unit of physical storage for data in a database. Usually a database contains more than one table, and the databases we will build and use in this course will all contain multiple tables. Here's an example of a database with multiple tables. This could be a simple database to be used by an online bookstore with different tables representing books, publishers, authors, customers, and their orders. Let's pick one of these tables. Let's pick the customers table and take a closer look at it. So this could be the customers table. As you see, it looks pretty much like an Excel spreadsheet consisting of columns and rows. Each column in this table is called a field, or a column, or an attribute, since it represents an attribute of the entities included in the table. The rows, on the other hand, are called records or rows. They each represent a self-contained entity. In this case, each record represents a customer, and each customer again has multiple attributes represented in terms of columns: name, company, phone number, and email address. What's missing in this table is an attribute that can uniquely identify each record in the table. When you take a cursory look, you could say the names of the records could be used as a way to uniquely identify different records. But if you think about it, you can always have more than one customer with the exact same name. That would apply to the company and even to phone number and email address, assuming that people may share phone numbers or email addresses sometimes. As importantly, phone numbers and email addresses of customers may change over time, so neither of those columns would be a stable way to uniquely identify the customers in this table. So what's the solution? A possible good solution is to use an artificial primary key field to uniquely identify the records in this table. In most cases, that would be a numeric field, the values of which can be generated manually or automatically by the database system. Most of the tables with which we will work in this course will involve a single column primary key. But it's possible for a table to have two or more columns to come together and form the primary key. An example would be a roles or performances table in a movie database, which joins an actresses table to a movies table. In this example, it's also possible to use a single column primary key that would involve an auto-increment field. Another important concept is the concept of foreign keys. Foreign keys are non-primary key fields which link the table where they exist to another table through that other table's primary key field. If you look at the structure here, you see a directors table and the movies table. And the director ID field in the movies table is a foreign key field. Because it's a non-primary key field in the movies table, it's not the primary key of the movies table, and it links the movies table to the directors table through the primary key field of the directors table, which also is named director ID. In this sense, it's possible to think of a relationship as a linkage between the primary key field of table A with a non-primary key field of table B. The table on the primary key field side is called a parent table, and the table on the foreign key field side is called a child table. Being a parent table or a child table is a relative concept, so a table can be a parent in one relationship and a child in another relationship. There are three main relationship types in relational databases: one-to-one, one-to-many, and many-to-many. In a one-to-one relationship, each record in table A corresponds to one record in table B, and each record in table B corresponds to only one record in table A. An example for that kind of a relationship would be between a passport table and a person table. In this relationship, each person can have only one passport, and each passport can belong to only one person. A one-to-many relationship is a relationship where each record in table A can potentially correspond to many records in table B, while each record in table B corresponds to only one record in table A. An example of a one-to-many relationship would be between a customers table and an orders table. Here, each customer may place many orders, but each order is placed by only one customer, or each order belongs to only one customer. Here's some other one-to-many examples. A many-to-many relationship is a relationship where each record in table A can potentially correspond to many records in table B, and each record in table B can potentially correspond to many records in table A. An example for this would be the relationship between an actors/actresses table and the movies table. Here, each actor and actress may appear in many movies, and each movie may involve many actors and actresses. Many-to-many relationships are not allowed in relational databases. The simplest way to explain why that is so is to think about an example like this. Here in this actors, actresses, and movies relationship, you would either end up with many columns in the actors, actresses table representing the movies, or you would end up with many columns in the movies table representing actors and actresses. Because some actors and actresses appear in hundreds of movies, and some movies involve hundreds of actors and actresses, you would end up with a large number of columns in one or the other table in this relationship. So what's the solution? The solution is to simply divide the many-to-many relationship into two one-to-many relationships by introducing a join table. The table in the middle in this diagram is a join table since it joins the two tables. In a structure like this, the primary keys of the source tables come together to form a composite primary key for the join table, or the join table is assigned a single column artificial primary key field, and the primary keys of the source tables are added to the join table as foreign keys. Another important aspect of databases is the concept of data types. For this discussion, I'd like to refer you to one of the readings on the Elm site, Database Modeling Building Blocks. Please do that reading, and if you have any questions, feel free to contact me. This concludes the first part of Module 1. You can continue with the second part that focuses on normalization in the other video.